The DNA clock switch telomeres telomerase. Can you slow cellular aging? Imagine that every time one of your cells divides, a tiny piece of its protective shield gets a little shorter. Not your DNA itself, but the protective cap that guards it. Now imagine this happening billions of times throughout your lifetime. This invisible countdown is happening inside every one of us. Scientists call these protective caps telomeres. Many researchers refer to them as one of the body's biological clocks because their shortening is associated with cellular aging. But here's the fascinating question. Can we slow this clock? Can simple daily habits influence how well our cells protect themselves? Today we'll explore one of the most exciting areas of longevity science, the remarkable story of telomeres telomerase and how your everyday choices may help support healthier cellular aging. Telomeres, like the plastic cap on your shoelace. Take a close look at a shoelace. At each end is a tiny plastic tip. Without it, the fibers begin to fray. Eventually, the lace becomes difficult to use. Your chromosomes have something remarkably similar. At the end of every chromosome sits a protective structure called a telomere. Although telomeres don't usually contain genes that code for proteins, they play a vital protective role. They help prevent chromosomes from fraying, fusing with neighboring chromosomes, losing important genetic information during cell division. Every time a cell divides, its telomeres become slightly shorter. This shortening is a normal part of biology. When we are young, our bodies repair damage efficiently. But as we grow older, the balance gradually shifts. Damage accumulates, repair slows, and telomeres continue to shorten. Your body's biological countdown. Think of your telomeres as the protective buffer on a pencil. Each time you sharpen the pencil, a little more of the eraser disappears. Eventually, there isn't enough left. Cells experience something similar. When telomeres become critically short, many cells enter a state called cellular senescence. These cells no longer divide normally. They stop contributing effectively to tissue repair. Instead, many begin releasing inflammatory signaling molecules, a phenomenon known as the senescence-associated secretory phenotype, SASP. Scientists sometimes call these zombie cells, not because they are dead, but because they remain alive while functioning poorly. Instead of helping tissues regenerate, they can contribute to chronic low-grade inflammation that affects neighboring cells. Over time, an accumulation of senescent cells is thought to play a role in many age-related conditions. What the research shows. A large study published in Aging Cell examined telomere length in thousands of adults. Researchers found that individuals with shorter telomeres tended to have poorer health outcomes and higher levels of fatigue. Shorter telomeres were associated with a greater burden of age-related health problems, although this does not prove that telomere shortening alone causes fatigue. Scientists now recognize telomere length as one marker of biological aging alongside many others such as inflammation, mitochondrial function, and epigenetic changes. The enzyme that rebuilds telomeres. Fortunately, your body has another remarkable tool, an enzyme called telomerase. Think of telomerase as a maintenance crew. Instead of allowing telomeres to shrink indefinitely, telomerase can help maintain and in certain cells extend them. For many years, scientists believed adults had little ability to influence telomerase activity. Then came a landmark study that challenged that assumption, the Dean Ornish study. In 2013, researchers led by Dr. Dean Ornish at the University of California, San Francisco followed men with early-stage prostate cancer who adopted comprehensive lifestyle changes. These changes included a whole food, predominantly plant-based diet, regular moderate exercise, daily stress management practices such as meditation and gentle yoga, strong social support. After 5 years, participants in the lifestyle group showed higher telomerase activity and evidence suggesting better maintenance of telomere length compared with the control group, whose telomeres shortened over time. Importantly, this study combined several lifestyle interventions, so it does not show that any single habit alone caused the changes. Nevertheless, it helped shift scientific thinking about the potential influence of lifestyle on cellular aging. Move your body, support your cells. Exercise is one of the most consistently studied habits associated with healthier aging. Research suggests that adults who engage in about 150 minutes of moderate physical activity each week often have healthier telomere biology than those who are sedentary. That works out to roughly 22 minutes a day. You don't need marathon training. A brisk walk is enough. A simple test is this: if you can comfortably talk but not sing, you're likely exercising at a moderate intensity. Consistency matters far more than perfection. Meditation and the DNA clock. Stress doesn't just affect your mind, it also affects your biology. Chronic psychological stress is associated with shorter telomeres and reduced cellular resilience. Researchers have explored whether meditation may influence this process. One interesting study found that practicing Kirtan Kriya meditation for 12 minutes daily over 8 weeks was associated with increased telomerase activity and improvements in markers related to stress. Kirtan Kriya is unique because it combines repetitive chanting, finger movements known as mudras, focused visualization, controlled breathing. These elements engage multiple regions of the brain simultaneously, making it both a cognitive and meditative practice. While more research is needed, meditation remains one of the best supported ways to reduce stress, a factor linked with healthier aging. Don't underestimate the power of sleep. The final pillar is often the most overlooked: sleep. Your body performs much of its repair work while you sleep. Research has shown that people who regularly sleep less than 6 hours per night often have shorter telomeres than those who consistently get sufficient sleep, though many factors can influence this relationship. Aim for 7 to 8 hours of quality sleep each night. Good sleep supports recovery, hormone balance, immune function, and overall cellular maintenance. Think of your telomeres as the protective caps of your genetic blueprint. Every healthy habit you practice is like helping the maintenance crew preserve those caps. A simple daily routine could include 30 minutes of brisk walking, a whole food plant-rich diet, 10-12 minutes of meditation or mindfulness, 7-8 hours of restorative sleep, meaningful social connections, avoiding smoking and excessive alcohol. These habits won't stop aging, but they may help your cells age more gracefully. Longevity isn't about finding a magic pill. It's about giving your body the conditions it needs to repair, adapt, and thrive. Today, you've learned about the second longevity switch, the DNA clock, your telomeres, and the enzyme telomerase. Healthy mitochondria provide energy. Healthy telomeres help protect your genetic blueprint. Together they form two essential foundations of healthy aging. Remember, every healthy meal, every walk, every good night's sleep, and every moment of calm is an investment in the billions of cells working tirelessly to keep you alive. Your daily habits become your cell's future.